We look up at the night sky filled with stars and galaxies, and a simple question arises: where did it all come from? How did this vast and intricate universe, with all its beauty and complexity, come into existence? For centuries, this fundamental question has captivated philosophers, theologians, and scientists alike. The answer, as far as we can tell, lies in an event of unimaginable power and mystery: the Big Bang. The idea that the universe had a beginning, that it wasn't always there, is a profound one. It challenges our intuitive understanding of time and space, and yet, the evidence overwhelmingly points to a moment roughly 13.8 billion years ago, when our universe burst into being. This wasn't an explosion in the conventional sense, like a firework going off in the night sky. It was the expansion of space itself, from a state of unimaginable density and heat into the vast and ever-evolving cosmos we observe today. The Big Bang theory is not just a guess or a hunch. It's a scientific model, built on decades of meticulous observations and supported by a wealth of evidence. This theory doesn't claim to have all the answers, but it offers the most comprehensive and consistent explanation we have for the origin and evolution of our universe. At the heart of the Big Bang model lies the concept of a singularity. This isn't a place or a thing in the conventional sense, but rather a point of infinite density and temperature, where the laws of physics as we know them break down. This singularity wasn't located somewhere in space, it's space. Everything that is, all the matter and energy in the observable universe, was once compressed into this infinitesimally small point. From this singularity, the universe expanded and cooled, with particles forming from energy, and gravity shaping the cosmos into the stars and galaxies we see today. The Big Bang, then, wasn't just the start of the universe, it was the start of time itself. The first few moments after the Big Bang were a period of incredible change and transformation. In the blink of an eye, the universe went from being smaller than an atom to an incomprehensibly vast expanse. During this epoch, known as inflation, the universe expanded at an astonishing rate, far faster than the speed of light. As the universe expanded, it cooled, and energy began to condense into matter. The first particles to form were the building blocks of atoms, quarks, electrons, and their antiparticles. These particles then combined to form protons and neutrons, the constituents of atomic nuclei. This early universe was a chaotic and energetic place, filled with a sea of particles colliding and interacting at incredible speeds. Yet, within this chaos, the seeds of structure were already being sown. Tiny variations in the density of matter arising from quantum fluctuations would eventually grow under the influence of gravity to form the stars, galaxies, and cosmic web we observe today. The Big Bang theory isn't just a compelling story. It's backed up by solid evidence. One of the most compelling pieces of evidence comes from the cosmic microwave background radiation, often called the afterglow of the Big Bang. This faint radiation, discovered in 1964, permeates the entire universe. It's a snapshot of the universe as it was just 380,000 years after the Big Bang, when atoms first formed and the universe became transparent to light. The pattern of this radiation tells us about the conditions in the early universe and provides strong support for the Big Bang model. Another crucial piece of evidence comes from the abundance of light elements in the universe, such as hydrogen and helium. The Big Bang theory predicts the precise ratios of these elements, and these predictions have been confirmed by observations. The expansion of the universe observed by Edwin Hubble in the 1920s is further evidence for the Big Bang. By measuring the distances and speeds of galaxies, Hubble showed that the universe is not static but is constantly expanding, just as the Big Bang theory predicts. Section 5. The Expanding Universe. A never-ending story. The discovery that the universe is expanding raises profound questions about its ultimate fate. Will the universe continue to expand forever, growing colder and darker as galaxies drift further apart, or will gravity eventually halt the expansion, causing the universe to collapse back on itself in a big crunch? The answer to this question depends on the amount of matter and energy in the universe. If the density of the universe is above a certain critical value, gravity will eventually win out, and the universe will collapse. However, if the density is below this critical value, the expansion will continue forever. Recent observations suggest that the expansion of the universe is not slowing down as expected, but is actually accelerating. This surprising discovery has led to the concept of dark energy, a mysterious force that seems to be counteracting gravity and pushing the universe apart. The nature of dark energy is one of the biggest mysteries in modern cosmology. Understanding this enigmatic force is crucial for determining the ultimate fate of the universe. Section 6. Before the beginning, the ultimate mystery. The Big Bang Theory describes the evolution of the universe from a very early state, but it doesn't tell us what, if anything, existed before the Big Bang. This question pushes the boundaries of physics and philosophy, leading us to the very edge of our understanding. Some physicists believe that the concept of before the Big Bang is meaningless. Time itself, they argue, came into existence with the Big Bang, so asking what happened before is like asking what's north of the North Pole. However, other theories propose that our universe might be just one in a vast multiverse, a collection of universes constantly being born and evolving. In this view, the Big Bang might not be the absolute beginning, but rather a transition from a previous cosmological state. String theory, a candidate for a theory of everything, suggests that our universe might be a three-dimensional brain floating in a higher dimensional space. Collisions between these brains could potentially trigger events like the Big Bang. While these ideas remain speculative, they highlight the limits of our current knowledge and the tantalizing possibility that our universe might be just one chapter in a much grander cosmic story. Section 7. Science and Faith, Two Lenses on the Cosmos. The Big Bang Theory, with its implications for the origin and evolution of the universe, has sparked much discussion about the relationship between science and religion. Some see the Big Bang as evidence for a divine creator, while others view it as a natural process that doesn't require supernatural intervention. Albert Einstein, whose theory of general relativity laid the groundwork for the Big Bang model, famously said, "Science without religion is lame, religion without science is blind." This quote highlights the complementary roles that science and faith can play in our understanding of the world. Science seeks to explain the natural world through observation, experimentation, and rational inquiry. It helps us understand the mechanisms by which the universe operates and provides a framework for testing our ideas against reality. Religion, on the other hand, addresses questions of meaning, purpose, and morality. It offers a framework for understanding our place in the cosmos and provides guidance on how to live a meaningful and ethical life. The Big Bang Theory doesn't necessarily confirm or deny any particular religious belief. It's a scientific model that explains a natural phenomenon. However, the awe and wonder inspired by contemplating the vastness and complexity of the universe can deepen our sense of spirituality and lead us to reflect on our place in the grand scheme of things. Section 8. A universe fine-tuned for life. The conditions that allow for the existence of life as we know it are remarkably precise. The fundamental constants of nature, such as the strength of gravity and the mass of the electron, seem to be finely tuned to allow for the formation of stars, planets, and the complex chemistry of life. This apparent fine-tuning has led some to propose the anthropic principle, which suggests that the universe is the way it is because we are here to observe it. In other words, if the universe were any different, we wouldn't be here to ask these questions. However, others argue that the fine-tuning problem might be a result of our limited understanding of physics and cosmology. Perhaps there are many possible universes, each with different laws of physics, and we simply happen to live in one that's hospitable to life. The question of whether the universe is fine-tuned for life remains a topic of debate and speculation. It's a question that pushes the boundaries of our scientific understanding and raises profound philosophical implications about our place in the cosmos. Section 9. The Big Bang's Enduring Legacy. The Big Bang Theory is one of the most profound and awe-inspiring achievements of modern science. It has revolutionized our understanding of the universe and our place within it. From a state of unimaginable density and heat, our universe expanded and evolved, giving rise to stars, galaxies, planets, and ultimately, life itself. The Big Bang is not just a scientific theory, it's a story about our origins, a cosmic narrative that connects us to the vastness of space and time. It reminds us that we are part of something much grander than ourselves, a universe filled with mystery and wonder. As we continue to explore the cosmos, new discoveries will undoubtedly challenge our current understanding of the Big Bang and the evolution of the universe. But even as our knowledge grows, the sense of awe and wonder inspired by contemplating the origin of everything will surely remain. The Big Bang Theory leaves us with more questions than answers. What existed before the Big Bang? What is the ultimate fate of the universe? Are we alone in the cosmos? These questions will continue to inspire generations of scientists, philosophers, and dreamers, urging us to explore the universe and unravel the mysteries of our existence.